Hi, in this video we are discussing about an improved round-robin scheduling algorithm for CPU scheduling. In fact, it's a slightly improved version of round-robin scheduling algorithm. Disk scheduling algorithms. CPU is a primary computer resource, so its scheduling is central to operating system design. To improve both utilization and speed of CPU, we need to keep several processes in memory at a time. That means we use the sharing and multiprogramming concepts. The core objective has been developed scheduling algorithms suited for certain goals, sometimes with probable properties. In case of multi-programmed operating system, CPU scheduling plays a fundamental role by switching the CPU among various processes. Operating system should allow process many as possible running at all times in order to maximize the CPU utilization. In a multi-programmed operating system, a process is executed until it must wait for the completion of some I/O request. In this case, the time has been used proficiently. There are many functions which are provided by operating system like process management, memory management, file management, input-output management, networking, protection system, and command interpreter system. In these functions, the process management is most important function because operating system is a system program that means that the runtime process interacts with hardware. Therefore, we can say that for improving the efficiency of the CPU, we need to manage all processes. For managing the process, we use various types of scheduling algorithms. There are many algorithms are available for CPU scheduling, but all algorithms have its own deficiency and limitations. In this video, we propose a new approach for round-robin scheduling algorithm, which helps to improve the efficiency of CPU. First of all, let's start with contemporary RR scheduling algorithm. The scheduler maintains a queue of ready processes and a list of blocked and swapped out processes. The PCB of newly created process is added to the end of the ready queue. The PCB of terminating process is removed from the scheduling data structure. The scheduler always selects the PCB at the head of the ready queue. When a running process finishes its slice, it is moved to the end of the ready queue. The event handler performs the following action. When a process makes an I/O request or swapped out, its PCB is removed from the ready queue to blocked or swapped out list. When I/O operation awaited by a process finishes or process is swapped in, its PCB is removed from blocked or swapped list to the end of the ready queue. So we can conclude easily RR algorithm is extension of FCFS algorithm. Only difference is we added the preemptive and time slice concepts. Scheduling criteria. The criteria includes the following: CPU utilization, throughput, turnaround time, waiting time, response time. Different CPU scheduling algorithms have different properties, and the choice of a particular algorithm may favor one class of process or other. In choosing which algorithm to use in a particular situation, we must consider the properties of the various algorithms. Many criteria have been suggested for comparing CPU scheduling algorithms. Which characteristics are used for comparison can make a substantial difference in which algorithm is judged to be best. The criteria include the following: CPU utilization. We want to keep CPU as busy as possible. Throughput. If the CPU is busy executing processes, then work is being done. One measure of work is the number of processes that are completed per time unit, called throughput. For long processes, this rate may be 1 process per hour. For short transactions, it may be 10 processes per second. Turnaround time. From the point of view of a particular process, the important criteria is how long it takes to execute that process. The interval from the time of submission of a process to the time of completion is the turnaround time. Turnaround time is the sum of the periods spent waiting to get into memory, waiting in the ready queue, executing on the CPU, and doing I/O. Waiting time. The CPU scheduling algorithm does not affect the amount of the time during which a process executes or does I/O. It affects only the amount of time that a process spends waiting in the ready queue. Waiting time is the sum of periods spent waiting in the ready queue. Response time. In an interactive system, turnaround time may not be the best criterion. Often, a process can produce some output fairly early and can continue computing a new results while previous results are being output to the user. Thus, another measure is the time from the submission of the request until the first response is produced. This measure is called response time. Is the time it takes to start responding, not the time it takes to output the response. The turnaround time is generally limited by the speed of the output device. So, we can conclude a good scheduling algorithm is open that is able to optimize the above performance measures. The optimization performance measures is to maximize CPU utilization, maximize throughput, minimize turnaround time, minimize waiting time, minimize response time, maximize scheduler efficiency. So we look at the proposed algorithm. Allocate all processes to the CPU only one time as like present round robin scheduling algorithm. After first time, we select shortest job from the waiting queue and its shortest job assigned to the CPU. After that, we select next shortest job and do step 2. Till the complete execution of all processes, we repeat steps 2 and 3. That means while all the process has not been finished or executed. In our proposed RR scheduling algorithm, we have combined the working of shortest job first scheduling algorithm along with contemporary RR scheduling algorithm. For doing this, we have done many experiments, but here I will discuss only 2 experiments because the issued results analysis is remain unchanged. Here we have 2 types of problems. One is with arrival time and there is without arrival time. First of all, let us consider with the arrival time. Let us assume that round robin quantum equal to 2. Then, according to contemporary algorithm, average turnaround time is 8.25 milliseconds, total waiting time is 18 milliseconds. According to our suggested algorithm, total waiting time equal to 14 milliseconds and average turnaround time equal to 7.5 milliseconds. Then consider without arrival time. Suppose RR quantum is equal to 5. Then according to contemporary algorithm, waiting time is 146 milliseconds. Average turnaround time is 42 milliseconds. According to our suggested algorithm, total waiting time is 131 milliseconds. Average turnaround time is 39.2 milliseconds. We can see from the above problem, total waiting time and average turnaround time both are reduced by using our proposed algorithm. The reduction of total waiting time and turnaround time shows maximum CPU utilization and minimum response time. We can say that proposed algorithm is much more efficient as compared to the contemporary algorithm. So we can see that our proposed algorithm is superior as compared to present RR algorithm. Since we know that RR scheduling algorithm is designed especially for time sharing system. So in near future we can improve time sharing system by using this algorithm. Thank you.